Hey there, Russ here. Welcome back to the shop. Well, today's the day. My batteries are going to be here for my power backup system. Um, they could be here within a half hour for the next 4 hours. So I'm anxious to get those so I can move along. I have got my, where is it? Let me do it this way. Right there. I have my electrical set up. I just finished that up yesterday. There's my main panel that's in here now. I have to upgrade it, but for now, so that I can get this thing up and running, I went ahead and just surface mounted a load center here, and I'm running it off of a 240 break, a double breaker off of this panel that then turns this panel on. And there's 3 breakers in here, one for the air conditioner and one for each of these 2 plugins. These are generator plugins, 330 amps, 240 volts, one male, one female. And I can move the switches back and forth depending upon what I'm trying to do with that load center in conjunction with my battery backup system. Most of the time, if I want to feed the house from the battery, I would turn the one receptacle on this side here, I think. Anyway, one of them gets turned on. That has the proper plug-in, so I can plug the input from the inverter of my battery system. I can plug that into that outlet, and I can backfeed the house. If the house is running off of the grid, that one would be unplugged, and the other one is plugged into the other plug-in, so that is then controls charging the battery while I'm on grid, so that if the power ever goes off, my battery will be at 100% and ready to use. Eventually, I want to run the whole garage off of this system and keep it separate from the house. But until I get solar, that's not going to be practical, which I'm going to probably do the solar. It'll be next year. If you hadn't guessed, Missy's standing right here leaning up against me, wanting me to pet her. So that's what I'm kind of doing. If you see me kind of, looks like I'm doing something. I'm giving her personal 5 minutes here that she likes to get. Eventually, she'll walk off and go play again for a while. Anyway, she's coming along as a good dog. She's still got some puppy left in her, and then once I got that gone, she'll be a very good dog, just like Annie is. So, in the meantime, I think that the other thing we're going to talk about real quick here is that I'm actually making a pretty small system for something that will run a whole house. For example, to run a house off of something that's out there now, rather than building it, is like the EcoFlow. Blue Eddy has one, Mango, and there's a couple others where you take 2 of their biggest units, and then you buy their hub, and then they each plug into the hub, and then the hub gives you 240 volts so that you can power the house. They usually have a 3,000 to 3,600 watt inverter on each of them. So on some of them, they actually go up to 7,200 watts, which is a little bit more than what I can do at 6,000. But 6,000 will actually run my house when the power is off. I'm not looking to stay off grid or to try to live as good as I do when I'm on grid. This is just to get by until I get back on grid. I don't want my freezers to thaw out, and I don't want my refrigerator goods to get warm, and et cetera, et cetera. I want to be able to get water, so I need the well pump to be able to run, and these types of things. So just to function. And near as I figure, I'm very lucky. Well, not lucky. I actually thought it through before I bought it. When I bought this house, I bought it because of many things, but one of the things I bought it for was that it was not all electrical. Now, I'm sorry that sounds negative, and I'm not trying to be negative here, but if you're going to end up any time being kicked off grid, not by choice, but you've got to be off grid, the more electrical equipment you have in your house, the more it's going to hurt unless you can put in a whole lot of battery and inverter and solar system in. And it takes a lot more to run those houses than what this house does. I have only 2 circuits that are 240 volts. One is the air conditioner furnace, It has a natural gas furnace and electric to run the AC units. The AC, a 2-ton AC. So when I'm plugged into my battery system and the power is, I'm depending on that to run the house, I can't run the air conditioner. No way this is near big enough, but I know that going in. But I can run the furnace. And that means that I can get by when the power goes out, even in the wintertime. I also can still run, the other thing I would have to do, the other thing I have to run that's 240 is my well pump. So that way I can still function and be in this house. Everything else is on 120 volts, and a lot of it I can do without when the power goes out. A lot of times when I do my cooking, for example, we use a microwave, we have a toaster oven, and I have an air fryer. And I probably use at least one of those every time I cook a meal. That would stop during the outage. I would just simply go use my gas stove and oven and be able to cook from that. So my needs of power in the house could be very, very minimum. So I could be able to get by for several days. I could probably get by for a couple of days on this battery system if I really was thrifty. But the other thing to keep in mind is that I also have in conjunction with that is my generator, so that every day I can run that generator long enough to recharge my battery system. So if I'm using 5 kilowatts a day because the power is out, then that means I have to run my generator for about an hour to regenerate that much electricity and put it back into storage to go another 24 hours. So every day I run my generator for whatever long my usage is of power. And as long as there's less power there is being used, the less that runs, and the easier and the smaller system I can implement to keep my house going when the power goes out. If my house had electric furnace and electric air conditioner and electric range and electric dryer, electric water heater, then you're going to need a much, much bigger system. So when I bought this house, one of the things that was important to me was to be able to be on a natural gas system. I gave a lot of thought to buying a house out in the countryside where there's even more freedom. But I decided that much isolation wasn't really necessary. In fact, I think it would be worse than living close to having close neighbors on an emergency if I had to. Depend on each other still. And in a small town like this, you do get that. But yet I still also have the luxury of having the electric power and the gas coming to my house. So when you decide what kind of size system you want, those are things you have to consider. And I am very glad that I don't need near as much as some of these guys because of the way their houses are set up. If you want to plan on being off-grid, or you're getting forced off-grid a lot, having electrical stuff in your house is actually very much a problem. So as we try to evolve into full electric power and nothing else, no fossil fuels, that's fine. But right now, for my needs, especially as a retired person, this has to be the way I do it. I'll let the kids worry about working everything out once I'm long gone, and they finally get it all worked out. But right now, I don't think it works very well for me to have anything less than the natural gas to help supplement what I'm doing. So anyway, with that in mind, that is why I also used the 6,000 watt low frequency inverter. I needed the low frequency inverter to run the well pump. But the biggest problem with those low frequency inverters is they do suck a lot of power in comparison. This thing uses, I think, I've heard varied amounts. This thing uses anywhere at the least that it's going to cost you is 115 watts an hour. And I have to tell you, now think about that for a second. That's a lot of power in one day. That thing if I have to run my power 24/7 off of this inverter, the amount of power it's using is 2.7 kilowatts a day. That just to turn the inverter on so I can have the electrical power available. That means that I'm using that thing just sitting there all day long in one 24-hour period. Half of one of those batteries is used up. That's why I have 3 batteries on there instead of 2. One battery, I really figure that gives me 2 days of running power on the battery that it's going to use. And that gives me 10 kilowatts left to use as my storage area. So that's why you really have to figure those things in. But just imagine if I had a lot of electrical stuff that I had to run from this thing, then instead of 10 kilowatts, I'd need 60 kilowatts. That's the problem. So I think I can get by with a lot less. And now I can add to this as I need to, too, because of the way I've designed this system and building it myself. When you use those, the other systems that are pre-made, they're okay. But you still really need to buy some kind of cart to stack everything on so you can just roll it around as needed when you're not using it. So you're gonna end up with almost the same size that I'm using here, a footprint, in order for this thing to be sitting around the house when not in use. So I think that mine is going to have some flexibility to it, and I have some other plans that I'm going to do to it to make it more flexible, so I can use it for example, as strictly as a 120 volt power instead of 240. So there's some things I have an idea. I also want to put together a small section of pulling 12 volts out of the thing so I can use it if I want to do some 12 volt stuff. Because some things you can run off of DC power instead at 12 volts. So I think this is going to be a great little full battery backup system for your house instead of those power units that you buy that are pre-rolled. Those are nice, but they are very limited, and if you ever want to expand them, that ain't going to happen. So, anyway, I just thought I'd give you an update of where I'm at, and give you an idea of why I'm going the way I am. I think I can run this house on that small amount of power. If I end up needing more, I'll do some other things, and we'll talk about it, so you can see why I'm making changes and why I design things the way I do. It fits my house and my needs. And if you want to talk about how you're doing yours to get some ideas, feel free. But also, if you decide to put some emergency system in or an off-grid system, hopefully some of the ways and my thoughts about how I do how I figured out how I was going to do it, it is a one of a kind and it will work. But in all reality, if you think about it, that's a great little package, putting all that stuff on one roll cart that you can roll around. It makes it a nice little portable outfit that you can take with you if you had to go out to a cabin for a weekend. This thing would be more than enough power to run everything you can imagine out there, including a well, if you have a well on that property. So I think there'd be some advantages to actually having everything, and having it on a cart makes it nice so you can have it pushed into a corner or into a closet somewhere when you don't need it for the house. Have it plugged in and trickle charged so that it stays relatively charged up. Power goes out, you grab it, plug it in, turn it on, and you're up and running. So anyway, I know that you can do other things with these, and they make great systems, but I like to keep it simple. So all mine's going to be a plug-and-play type of stuff. When I want to do something different, I just have to plug things in differently and turn on different switches. But just remember the number one rule. I have a breaker in there that I have to flip in order to do some of the things that I want to do. Because you want to make sure that more than anything, that if you're going to create your own power and put it into your house, you cannot have that main breaker on the main panel at the house. That has to be off, because you do not want to take any of your power and push it back onto the grid, period. So anyway, just a food for thought. I'm still learning about some of this. I like the way this is going. I think it'll be a great functional unit for me on my house, so that at least when they stop giving me power, I can still function. And that's the main goal. And I can do it actually pretty cheap because I'm going to have in this system so far between the generator and my battery backup that I'm going to have, the battery generator. The only thing left will be the solar. But so far on my budget, I probably will have probably $8,000 wrapped up. In comparison to, just think about having some kind of backup system in your house. Just the generator alone, a lot of the times you'll spend $20,000 with some of those or more for some of those units out there. So I think I'm getting by pretty cheap. And you can do it yourself if you take the time to learn some of the basics. I am lucky because I do have a good working knowledge of working around AC electric volts, and I have a very extensive background in experience in working with DC volts. So I think that between those two, it helps me to be able to do this myself. And if you don't have that kind of experience, then you need to make sure you learn it and learn to understand those things. And there are people out there that do. So don't follow the things I do, but you can get some good ideas of how to make your system from things that I do. So, but don't do something just because you think I do it and that's the way to do it, because you want to make sure that you do things very safely and that make it very comfortable for you when you're using it. So anyway, I want to thank you for coming by. If you have any thoughts, any questions, just leave them in the comments below. I do read them all, and I do appreciate your thoughts. So, if you learned something here, you like this video, hit that like button. Lets me know that I'm doing something right. Most importantly, though, please come back again because I'm nowhere near done. Thanks, and we'll see you guys again very soon.